Next, we're going to talk about how a profit-maximizing firm chooses how much to produce. So here's a question for you. If a perfectly competitive firm is a price taker, who or what sets the price? Well, I actually already mentioned this in the introduction. It's the market that sets the price. The market determines the price through supply and demand equilibrium. So equilibrium price is the price that the perfectly competitive firm has to take as given and has no control over it. All right, so let's look at an example. Okay, so in this example, we have a perfectly competitive firm that is selling a homogeneous good, and it's going to be selling its good at the market price, which we are going to assume is $5. It's not going to be able to sell at a higher price simply because since it's selling a homogeneous product, and if it tried to sell at a higher price, consumers would just go to one of its easily accessible competitors and buy at the market price. So ultimately what this will mean is that the individual firm is going to face a horizontal, perfectly elastic demand curve. All right, so this is what we have. Over here is the market with the usual supply and demand curves, and in equilibrium, the equilibrium price is $5, which is the price that the individual firm is taking. Now for the individual firm, its demand curve, little d for individual demand curve, is simply a perfectly elastic demand curve at $5, which basically can be translated as the firm can sell as much as of its product as it wants at the equilibrium price. Okay, so in this case, the example is portable power banks. So let's think about why it has to be a price taker, right? If it tried to raise the price, it would sell nothing. People would just go to its competitors and buy at the lower market price. If it tried to lower its price, it wouldn't be able to sell any more than it already could because of the perfectly elastic demand. And it really would just be taking a hit in terms of profit or revenue. And so that's why the firm is a price taker. Now, it has to decide, given these conditions, how much to produce, and it basically is interested in maximizing profit. So it uses a profit maximization model to determine how much to produce in order to maximize profit. All right, so maybe not surprisingly, the model assumes that the firm is trying to maximize its profits, which is simply the difference between revenues and costs. So revenue is the money that the firm makes by selling its product, but that of course is not its profit because it costs money to produce the goods or services that it sells. So in order to get to profit, we have to subtract the costs of production from the money that it makes, from total revenue. Now, as it turns out, the model is basically another way to think about the same problem. Rather than thinking of maximizing profit, the same solution is to minimize costs, or losses, in other words. Sorry, not costs, but losses. Okay, so which a loss is just when revenues are not greater than costs, or when costs are higher than revenues. That would be a loss. So minimizing losses is the same as maximizing profit. All right, so how do we calculate total revenue? It's simply price times quantity. Okay, it's the per unit price times the number sold, so the quantity sold. And it's the same as the total receipts from the sale of output. So when the firm sells what it produces to consumers, the money that it receives for selling that good or service to consumers is total revenue. So just P times Q. Right, so here we go. What's the equation for profit then? It's total revenue minus total cost. And since total revenue is price times quantity, We can replace total revenue with P times Q if we wanted to. And then recall that total cost is the sum of total fixed cost and total variable cost. So we could also replace total cost with total fixed cost plus total variable cost if we wanted to. Now recall that price is determined by the market equilibrium price, and Q is determined by the producer, and it's the quantity that maximizes profit. All right, so here we've got a huge table illustrating profit maximization. So over here we've got total output, so the quantity that the firm chooses to produce, and then various variables that follow suit. So here we've got total cost for each level of production. We've got market price, which of course is staying the same since the firm takes that price as given from the market, and it's $5. And then here's total revenue, which is just the price times the quantity. Okay, so of course when the firm produces 0, total revenue is 0. If it produces 1, total revenue is 5. If it produces 2, total revenue is 10, and so on. So just price times quantity. And then profits, total profits is going to be total revenue in this column minus total cost in this column. All right, and then we also have average total cost, which is just total cost divided by quantity. And we have average variable cost, which is just variable cost divided by quantity. And then also for illustration, we have marginal cost and marginal revenue. Now graphically, we can think of or look at profits and losses in this way. So this green line here is revenue, total revenue, which is price times quantity. So of course, since price is constant, basically the slope of this line is price 5, and then we multiply by quantity. That's why it's a straight line, basically. And then we've got total cost is this black line here. Okay. And so recall that profit is the difference between total revenue and total costs. So when costs are above total revenue, we have a loss, as illustrated here in these red regions. And when revenue is above costs or greater than costs, that's when the firm experiences profits. And the firm's goal is to maximize basically this positive distance between revenue and costs, right? So get this green line as high above the black line as possible, or at least get it as close as possible. So in this case, the firm is able to make a profit, and it wants to basically make this gap here as big as possible, which occurs right here at this point between 7 and 8 units. What we also saw in the table was marginal cost and marginal revenue, and if we graphed them, it would look like this. Now, as it turns out, marginal revenue is just the same as the demand curve, and we know already that the demand curve is just a horizontal line equal to the market equilibrium price. Okay, so that's marginal revenue. It's $5. Marginal revenue is $5. And then we also had a marginal cost curve that kind of has this U shape, which is the standard shape for the marginal cost curve. And as it turns out, recall that this is where profit is maximized. As it turns out, the condition for profit maximization is to produce the quantity where marginal revenue equals marginal cost. And to understand why that's the case, for all of these units over here, marginal revenue is greater than marginal cost, which means that if you produce that unit, since the additional revenue is above the additional cost, you're making additional profit on these units, right? So all of these units here, for each unit that is produced, there is additional profit. And that's true all the way up until this point where they're equal. Now, if the firm continued producing beyond that point, at this point now the additional cost is above the additional revenue. And so this would lead to, if the firm were to produce these units out here, this would lead to additional losses, okay? So that's why profit is maximized where marginal cost equals marginal revenue. Okay, so let's take a break real quick and think about a behavioral example. Do competition and bad behavior necessarily go together? Which is sometimes an argument that's made, right? Competition can lead to things like cheating and other bad behaviors. So some behavioral economists have found that people who exhibit less trustworthy characteristics are more likely to engage in competition. Yet, they have also found that honest people are more productive if they elect to compete. So firms that engage in intense competition tend to hire individuals who are altruistic and trustworthy. So kind of mixed evidence here on this question. Interesting question to think about. All right, let's get back to the problem at hand, profit maximization and the firm's decision on how much to produce. So the rate of production that maximizes total profits, in other words, the difference between total costs and total revenues, is also the rate of production at which marginal cost equals marginal revenue, as we've just seen a couple of slides ago. And hopefully my description of why that's the case was easy for you to understand, right? So recall marginal revenue, marginal meaning additional revenue, right? We can calculate this as a change in total revenue divided by a change in quantity. So that's how we calculate marginal revenue. And similarly, marginal cost is a change in total cost divided by a change in quantity. So very similar to the marginal equations we've already seen. And again, profit maximization occurs when these things are equal. So this is, right here, our profit maximizing rule.